Hi and Assalamualaikum. My name is Muhammad Kamil Izzas bin Osman and I'm going to explain about Digital Logic Lab Sheet 3 for question 1 and 2 in part A. For question 1, you need to draw a single JK flip-flop in the simulator. First, we are going to use JK flip-flop pad. Next, we are going to use 4 input switches. 1, I label it as preset. Next, I label it as J. Next, K. Next, clear. Then we are going to use clock generator for the input. I label it as clock. And we are going to use two output switches for Q and Q bar. For the last thing, we are going to connect all the circuit. 1, 2, Alright, it's done. And that's for question 1. For question 2, we're going to stimulate the circuit to determine the logic level for each input combination in table 1 so that the desired output can be produced. For A, we set the initial value for Q is equal to 0. This one is equal to 0. And to do it, we need to set the preset value as high. 1 and 0. Output Q stays in the same synchronous mode, 1 and 1. And when it is in synchronous mode, we need to and for the clock, it need to be negative edges. Okay, so for the preset, it is 1 and 1, also 1. And when it is synchronous mode, we need to use the value for the JK, and for Q, it also Q. Output Q become 1 in asynchronous mode. To make it as asynchronous, we need to change the value for the preset is low, and we get it as 1. When it is in asynchronous, it is don't care the value for JK, high for clear and low for preset. For question D, output Q is not the same as the previous Q, and we're going to set the preset and also the clear by 1. So we use the synchronous mode, and for JK, since it not the same with the previous one, we're going to use toggle and 1 and 1, and we get 0 for the output. For set Q is not the same as set Q in asynchronous mode. To set Q in asynchronous mode, we need to set it as 0 for preset. And for JK, we don't need to change the value because we don't care the value or whatever it is, 0 and 1. And for JK, it is don't care and also don't care. For output is Q1, okay. And for the last question, we set Q in synchronous mode. To change it in synchronous mode, the preset and clear must be in high. And reset, and to reset it, we need to change the value for J 0 and K is 1. And we get the reset value 1, 0, 1, 1, 1, 1, 1, this is 0, my mistake, and the output for Q is 0. And that's all for question 1 and 2.
Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, doctor. My name is Ammar Mustafa. Today I'm going to explain about question 3 and 4 from part A. So let's start with the first question. Which state the JK flip-flop has, but not on SR flip-flop? So JK flip-flop has toggle state, while SR flip-flop does not have that toggle state. So question 4, identify whether the JK flip-flop in 7476 is a positive edge triggered or negative edge triggered flip-flop. It's negative edge triggered flip-flop.
Next, I would like to present the Part C analysis of a synchronous counter. The question wants us to complete the circuit until it can work as a counter. So actually we found that we are missing the wires that connect to the present stage and kill stage. So we build it like this. We just connect both of them to logic level 1 because when both of them are 1, the asynchronous inputs are inactive and the flip-flop are free to respond to D and clock input. Next, the question 2 asks us to complete the next stage table of the counter in table 3. So before we complete it, we need to know the Q0 and Q1 is equal to what. So actually we refer to the theory, we know that Q0 is equal to D0 and Q1 is equal to D1. So we need to refer to the circuit to find that D0 is actually equal to Q0 plus S prime and the D1 is actually equal to S prime Q0 prime plus S Q1 prime. So after we know that, we can put our value to the expression and then we can find that our next stage value. So like example, the first one is our next stage of Q0. So refer to D0 here. S prime plus Q0. Our S value is 0, Q0 is 0. So we can find 0 prime plus 0 equal to 1 plus 0 and our final value will be 1. And our Q1 is equal to D1. So D1 is actually S prime Q0 plus S Q1 prime. So we just put the value here. So 0 prime plus 0, 0 prime equal to 1, 1 plus 0, 1 equal to 1 plus 0. And our final value will be 1. And the left is actually same with this. So the question 3 asks us to sketch the stage diagram. So before we sketch it, we need to know our output Z. So refer to the circuit. We can find that our Z is actually equal to SQ0 prime. So after we know that, we can build this table. So D1 and D0 is actually same with our Q1 and Q0. And our Z value is actually just put the value to the expression. So for example, the first one, SQ0 prime, our S value is 0, Q0 is 1. So it's 0, 1 prime equal to 0, 0. So our final value will be 0. And after we complete this table, we can sketch the stage diagram. So refer to the table, we know that we have 4 stages, 0, 0, 0, 1, 1, 0, and 1, 1. So after we sketch the stage, so we can sketch our stage diagram like 0, 0 will go to 1, 1. So when our input is 0 and our output will be 0. So 0, 0 go to 1, 1. When our input is 0 and our output will be 0. And next, 0, 1 go to 0, 1 when our input is 0 and our output will be 0. 0, 1 go to 0, 1 when our input is 0 and our output will be 0. Next, 1, 0 will go to 1, 1 when our input is 0, our output will be 0. 1, 0 go to 1, 1. 1, 0 go to 1, 1 when our input is 0 and our output will be 0. Next, 1, 1 will go to 0, 1 when our input is 0, our output will be 0. 1, 1 go to 0, 1. 1, 1 go to 0, 1 when our input is 0 and our output will be 0. Next, 0, 0 will go to 1, 0 when our input is 1 and our output will be 0. 0, 0 go to 1, 0. 0, 0 go to 1, 0 when our input is 0 and our output will be 0. Next, 0, 1 go to 1, 1 when our input is 1 and our output will be 1. 0, 1 go to 1, 1. 0, 1 go to 1, 1 when our input is 1 and our output will be 1. Next, 1, 0 go to 0, 0 when our input is 0 and our output will be 0. 1, 0 go to 0, 0. So here, when our input is 1 and our output will be 0. Last, 1, 1 will go to 0, 1 when our input is 1 and our output will be 1. 1, 1 go to 0, 1. 1, 1 go to 0, 1. So when our input is 1 and our output will be 1. The question 4 is what is the main indicator to decide that the counter is a synchronous counter? So our answer is the clock inputs across all the flip-flops yield the same source simultaneously. So refer to the circles. Here we can know that our FF0 clock and our clock for FF1 is actually connected to the same source. So we can know that this circle is actually a synchronous counter.
So I'm Zulaika, so I'm going to explain part C. The first question I will answer is the question 5, which is how many states are available for a counter and what are they? There are 4 states where it is mod 4 because of there are the 2-bit counter. And for question 6, what is the function of switch X in the circuit? Switch X add extra input that cause transition from present state to next state. So for question 7, what were the missing wires that were not drawn in the original figure 2 and what are their functions? So the missing wire that were not drawn are wires that connect to the PR, which is preset, and CL is referred to clear. There are asynchronous inputs, which means that the output replies to them instantaneously, which is PR, which is preset, sets the output to 1, and CL, which is stand for clear, reset the output to 0. So for the question number 8, list all the characteristics of this counter. So the first characteristics is the non-cyclic counter. The counter does not go back to first count after maximum count, and the next characteristic is saturated because the counter repeat the maximum count if count up or repeat the minimum if count down. That's all from me. Thank you.